Okay, guys, so now let's do this problem here. What we have is a diagram below. We are told that CA is a tangent to the circle with this diameter here, and another important statement is that CD and DB have this ratio of 2:3, right? And the first question says we should prove that AD squared is equal to 6x squared. So AD, it's just this line here, right? AD squared. So how we can go about that is, I think it's by proving that these two triangles are actually similar. This triangle here is similar to this triangle here. We need to prove that. That will help us in figuring out how to go about this. Why do I even assume that similarity will help? If you see it, that this AD squared, if you remember the previous questions that we've done, whenever you have AD squared, it's a corollary, however you pronounce it, but it's a corollary of coming from those similar triangles. So that's the assumption that this might be the corollary. So we need to prove similarity between these two triangles. So the first thing I'm going to do is just figure out, because for us to prove the similarity of these two triangles, we need to look at what's common, what's common between these two. But before we even get to that, I just want us to figure out how we can work around that first, with what we have, right? We are told that here it's 2:3, right? 2:3 like this. And another thing, we are told that this is a tangent. So if it's a tangent and this is a chord, which means this angle here of A1 is equal to this angle B, right? So that's the first thing we can detect, is that angle A1 is equal to angle B. Reason is tan chord theorem, right? Fine. So after proving this, I want you to take note of something. We're told that this is a diameter, right? We're told it's a diameter. So diameter subtend a 90-degree angle at the circumference, right? So which means angle D2 is equal to 90 degrees. Reason is that angles on semicircle, angles on a semicircle, right? Since AOB is a diameter. So that is that. And then once you've proven that it's 90 degrees, therefore angle D2 is equal to angle D1 is equal to 90 degrees. So that's what's going to happen, because it's a straight line. And then from here, let me just erase. From here, you're almost, or you're practically done. So I just found this information here, which will help us looking at this triangle. So let me draw these two triangles that we're talking about here. So we're talking of ADC. So this is your 90-degree angle that we just proved. And then we have another triangle that looks like this, 90-degree angle. And we have B here, we have A2 here, and this is A1. And then this is D, right? D2 here and D1 here. Fine. So, as I said, we need to prove the similarity of these two triangles. So, just by the previous working out, you can just take that, okay, this A1 is actually equal to this B. So, that's the first thing. Angle A1 is equal to angle B, right? You can state this reason. Tan chord theorem, right? Fine. And another thing is this angle here of 90 degrees is equal to this one here. So it's angle D1 is equal to angle D2 is equal to 90 degrees, right? And how did you prove that? We proved that using the diameter, right? Diameter AOB. But the basic reason is angles on semi circle. Right, fine. So since we've proven these, then we are left with this one here, 1 2 3 4. So this is just going to be the third side, right? So angle C is equals to angle A2. Reason is third angle of a triangle, right? So you've proven three things. You've proven this, you've proven this, you've proven this, you've proven three angles. So therefore, our triangle ADC is similar to triangle BDA. So it's important that you write that properly, just to avoid any mistakes. So once you've proven the similarity, then you'll be able to solve the problem, right? You'll be able to solve the problem. So let me erase here. So not forgetting, we still haven't answered this question, so we're still doing it. So we have proven that triangle ADC is similar to triangle BDA, right? So from this stage, because I told you that this is a corollary, we need to establish those corollaries by first identifying the ratios, right? So this AD divide by this BD, right, is equals to, and then the last two, DC, divide by AD, is equals to AC, like this, over BA. Fine. So now this is the ratio coming from the similarity triangles proof. So from this stage, you're going to look, because this is AD squared, you're going to look where there's AD in both ends, right? If you take a look, there's AD here. And if you take a look here, there's also AD. So you're going to take these two. So you have AD over BD is equals to DC over AD. Fine. So what you'll do, cross multiply. You have AD squared equals to BD multiplied by DC. Fine. So once you found this, I want to take note of something. BD is this side here, and we were told that BD is 3, right? So it's 3x. Fine. And then DC, this is this one here, which is 2x, right? So meaning BD, it's 3x multiplied by DC, which is 2x, like this. So which means AD squared is equals to 6x squared. So this is going to be a final answer for this problem here. And then now we move on to the last question, right, where we are asked to prove whatever that is happening here. So for us to prove this, I want you to take note of something here, is that there's AD squared, which is actually this. So you can simply say AD squared is equals to 6x. So this was proven. So you already know AD squared, and in this case, you just want to simplify this equation. So for you to do that, let's just take what we have and try to remove with what we don't have. So this here, we have AD, so which means if you put your, we have AD, and then these AC and AB are these sides here. So meaning that if we were to focus on the bigger triangle, not the two small triangles, but the bigger one. Why? Because there's AB on the bigger triangle. There's also AC. So this is the AB I'm talking about. This is the AC I'm talking about. Right? Fine. So what you will do is you say triangle ACB, right? Looking at the bigger triangle, what do you see? So what I can tell is that angle A1 plus angle A2 is equal to 90 degrees. That's what I can tell you. So, which means here it's 90 degrees. The reason here is radius perpendicular to chord. Right? Fine. So once you've done this, now what you will do is you're going to write down the equation of Pythagoras for this big triangle, right? So you're gonna say CB squared is equals to AC squared plus AB squared. So this CB is equals to what is written here, right? So here's what we will do. Remember, we still have an idea on how to go about this CB. CB is the entire thing from here to here, which the smallest one was 2x, and then here it was 3x. So you combine both, it's going to be what? 5x. So it's going to be 5x squared is equals to AC squared plus AB squared. So meaning it's 25x squared is equals to AC squared plus AB squared, right? So this is what we have. And then from here, what's important is recognizing this, right? Which is basically that, right? So what you will do is you're just gonna draw, let me just erase this. But first write that 25x squared is equals to AC squared plus AB squared. So what I'll do is I'm just gonna erase here. So what's gonna happen is you have 25x squared is equals to AC squared plus AB squared, right? And this we have proven. So but the square root is what? Square root, it's AD squared plus AC squared plus AB squared is equals to x, the root of 31, right? So how do we go about it? We already know that these two, when you combine them together, it's going to give you this, which means you're going to say AD squared plus 25x squared, of which we also know AD squared. We've proven it in the previous question. So which means it's going to be what? 6x squared plus 25x squared, and you're going to get 31x squared, and then if you punch the square root for x squared, it's going to be x multiplied by the root of 31. So this is going to be your final answer for this question here of 10.2. I hope